All right, where we last left off. So AC circuits, what do we do?
It means alternating current.
Yes. All right. So I guess we know that. So what does that mean?
Does that make sense?
I think you're making a correct hand gesture. You said something that I missed.
It can change like the direction of flow, unlike our other currents where it has to go a specific way.
Okay. Direct current. That's the direct current. Yes.
Thank you.
Alternating current alternates directions. In the U.S., how often does it do it? How many times a second?
Pretty often.
True.
Is it 50?
Would you say?
50?
No, that's Europe.
60 years?
60. 60 times a second. U.S., Canada, Mexico. Ohm's law. What are the 3 Ohm's law, or 4 Ohm's law style equations? Or if someone wants to start out, tell me what Ohm's law is.
V equals IR. Delta V equals IR.
Yeah. Delta V equals IR. All right, so when dealing with AC, well, there's one of them right there. Delta V across a resistor is equal to the current across a resistor times the resistance.
VC is equal to IC.
Is it VE?
C. C.
C.
The capacitor. Is equal to the current X C.
Right.
X.
Delta V or is equal to, oh, there you got the plus resistor. Hold on. Delta VL is equal to current L XL.
And then voltage of the power supply is equal to the current across the power supply times the impedance.
All right. So we have this X of T, X sub C here. What does X of C equal?
1 over omega C.
And X of L?
Omega L.
And Z?
You usually determine it based on the setup of them.
All right. Property dependent, prop depth. Oh, lagging and leading. So for a resistor, does the voltage cross the resistor or the current through the resistor? Which one leads, which one lags?
This
They're in phase.
interface.
All right, what about for a capacitor?
Leads E by 90 degrees.
Say that again?
I leads E by 90 degrees.
Oh, okay.
Well, that's what we wrote it then, but then we changed it back to V.
Yeah, because it's physics, not engineering. I leads V by 90 degrees. And for an inductor?
The voltage leads.
Yes, it's the other way around. VL leads IL by 90 degrees, or we also could say, that's an L there, IL lags VL by 90 degrees. All right, so that's what we have. Anyone want to take a shot at what a phasor is?
Phasor is like a spinner rotating counterclockwise about an axis.
Sure.
That's what you said last time.
It's a model of any definition we have other than it's like a spinner. It really, I think it's just words and pedantics. All right, so we've done the series circuit, we've done the parallel circuit. It's time to mix it up. Let's go for a complicated one. Now, there are two ways, there are several stages. One is the phasor diagram, which should be within the scope of this course. There's then also finding Z, which might or might not be within the scope, depending on how complicated I make it. And then there's actually coming up with the equations. And so if it gets too complex, I subject the 252 class to that. And where is that? So RC parallel, the L circuit, RLC. There we go. So what we do is we're going to put in a power supply here. Put a resistor into it, and then we'll have an inductor. So this is one where we should be able to come up with the phasor diagram and come up with a value for Z, for the impedance. Let's officially make some markings here. That's resistance R, that's capacitance C, that's inductance L, and this is amplitude of epsilon. Now this one's trickier in the fact that, yeah, we do have a parallel component, and that parallel component is in series with R and epsilon. It's a question of what do you start with? I mean, with if it's all parallel, then starting with the voltage phasor makes sense. If it's all series, starting with the current makes sense. But on something like this, what do you do? My recommendation is to start with well, if you were simplifying this, if it were all resistors and I said, what is the equivalent resistance, what would you start with?
If you asked what?
If these were all resistors, let's go flashback to DC circuits. DC power supply, resistor, resistor, resistor. If I said, what is the equivalent resistance, what would be the first group that you would do?
Parallels.
Yeah, and we will start there. Let's draw it up. So they're in parallel, so what's going to be common to the two of them?
So what's going to be common to them?
Either voltage or current.
Current. The same current. No, wait, the same voltage.
Voltage.
You're
I-
speaking
I
with electrical
concur.
confidence. You look like you're
I
hesitant.
agree.
You agree, okay.
I agree.
Or he agrees with you.
Yeah.
Yeah.
It is voltage. You will not have necessarily the same current if if there's some junction in between. All right, so we'll start out with my voltage phasor, and I'm gonna just write it VLC, which is the same as VL, which is VC. How many phasors are we actually gonna have? Oh,
8.
yes. So this counts as 2 of them. VLC is just a shorthand since it's the same voltage. I know that, well, actually, now I have the voltage for the inductance and for the capacitance. I should be able to figure out the current for the two of them. What's the current for the two of them?
For the inductor, the current lags behind by 90 degrees.
And so the rest of the class gonna make Luis do this.
And the capacitor, the current leads by 90 degrees.
Now, again, I don't know whether IC or IL is longer. I do not know, based on what has been given, do not know. Let's go ahead and figure it out. I have to give some numbers here.
Let's go with what we had done before, at least in the ballpark. And do I have anything with numbers here somewhere? I do. So I did 200 millihenries. And
So let's make this 2 micro ohms, oh, sorry, microfarads, and 150 millihenries. And we'll make the resistance. We do need one other piece of information here. The fact, I need to know what the frequency, where are we? Let's go international. So the frequency is 50 hertz. And I need to figure out omega. So how do we find the angular frequency if I know the frequency?
Oh.
2 pi times frequency.
So 314. All right. Okay. Units.
Radians per second.
Now, as I'm drawing my current vectors, or current phasors over there, I know that my current phasor is gonna be equal to my voltage phasor over my reactance. So, L's there, or actually VLC, and then I sub C is technically VC, but it's the same as VL over X sub C. So what we're looking at to figure out which is bigger, IC or IL, it comes down to the reactance. The bigger the reactances, the smaller the current phasor is. Well, we have formulas here. So X of L is equal to 314.159 radians per second, times my inductance, which is 0.2 henries. Oh, no, wrong problem, not 0.2. 0.15 henries. And what is the inductive reactance? If someone would be kind enough to calculate that.
We're supposed to be in radian, right?
You said something about radians?
Yeah.
Is it radian mood? It doesn't matter, you're just multiplying numbers.
47.12.
0.12 units. Luis, I think you were about to say it.
Ohms?
Or henries per second if you want. Or Henry radians per second. All right, that's X of L, so X of C is 1 over omega C, so that's 1 over 314.159 radians per second, times my capacitance of 2 times 10 to the negative 6 farads.
Sorry, I'm making sure I get it right. 1591.55.
Anyone else got that?
Yeah.
I'm gonna change some numbers then. I don't like that. 200 farads. Oh, I read it wrong. It is. Let's make that 40. Change this to 40. Change that number, hopefully that'll bring it more into the ballpark. So with this new number, $70 something.
I got 79.58 ohms.
Or if you'd rather, seconds per radian farad, or second per farad. All right, so which one should be bigger, IL or IC?
Which one should be bigger? IL will be bigger.
Yes, because we're dividing the voltage across them by a larger number for the capacitor than we are for the inductor. And matter of fact, it is not quite half the length. So what I'm gonna do is, let's see if I just hold that to go away. No. How do I accidentally? Okay. There's a small little detour. So we now know the two current phasors across here. I know that whatever the current is for going across the resistor or the power supply, that splits into those two. In other words, the current across the resistor is just the sum of those two. Well, the sum of those two would be a phasor pointing into the fourth quadrant. And so this is IL minus IC. And that's going to be the current across the resistor and the current across the power supply. Or out of the power supply, through the power supply. Yeah, that's a straight line. So I now know the voltage, sorry, I know the current across the resistor. Where does my voltage for across the resistor go?